Hello, dear students. Welcome to the channel. From today onwards, we are starting a very new course which is called Signals and Systems. This course is normally offered in electrical engineering and EC engineering. In electrical engineering, it is generally offered in either fourth or fifth semester, and this course is will be very this course will be very grounded course. Um, we will be discussing what is signal, what is system. So we will be starting from the very basics about what is signal, what is system. We will know what are the properties of both, what are the operations which will be performed on both of the signals and systems. We will be going through different analysis of signals, different analysis of systems. We will be seeing different transforms like Fourier transform, Laplace transform, Z transform, all the types of transforms which takes place on the signal, any signal. So this will be the very basic course about signal and systems. And if you are into signal processing thing or image processing thing, or if you are trying to make a career in even computer vision as well, so for that this is the very base. And in this course we will be discussing about uh, all all type signals and system which can be seen, and we will try to cover as max as possible. Even though this is not a signal processing course, so please do not expect the lot of signal processing. But even though this is a basic course, the course involves a lot of mathematics. The course involves a lot of mathematics, so I would want you all to tilt your calculus hats for a little, because you will be seeing a lot of derivation, integration, in time. Okay, so without further ado, let's start from the very basics. Let's try to know what is a signal. Okay, so coming to the signal, what is a signal? So signal is a function of one or more independent variables. It is a function of one or more independent variable which contains some information. Okay, it can variable can be anything, the information can be anything, but a function must be there. Okay, function must be there, and there will be one or more independent variables. For example, you can say uh, any type of voltage, electric current, radio signals, you can say telephonic signals, computer signals, right? All these types of um, things are example of signals. And these signals like electric voltage, current, radio signal, TV signal, telephone signals, okay, those signals are called electric signals mostly. Okay, but the signals which do not contain electricity, like the pressure signals or sound signals, these signals are called non-electrical signals. Now coming to the system, that what is a system? So system is a set of set of elements. Okay, set of various elements, or you can say functional blocks, small functional blocks which are connected together, and after connecting them together it produces an output in the response to the given input signals. Okay, repeating again, a system is a set of elements or functional blocks that are connected together and produces an output in response to an input signal. Okay, what are the examples of a system? So any type of amplifiers like audio amplifiers, okay, attenuators, TV sets, anything that receives a signal like antennas, okay, transmitters, all these things are called signals. Every single machine, okay, every single machine is a system. Every single engine is also a system. Okay, so all these things forms a system. Now to make it more clear about what is signal and what is a system, let's discuss about the relationship between signals and systems that we will be exploring over here. So every system, every single system that exists, it has either one or more than one inputs, and those inputs are called excitation. Okay, and similarly as input, every system has either one or more than one outputs, and we call that output response. Okay, if you have studied control system theory, in that you would be familiar with these terms, excitation and response. Okay, always remember the output and input of any system will always be a signal. The input given to a signal will always input given to a system will always be a signal, and output which we will be receiving from the system will again always be a signal. Okay, for an example, we've taken a system over here which is nothing but a simple audio amplifier system. Okay, we have discussed in previous slide that amplifiers are system. Okay, so what will be the input signal to the audio amplifier? The noise is the low level noise. The audio signal will be the input signal for the audio amplifier, right? And after the system which is nothing but a functional blocks, or you can say set of elements, it will be done with that signal. It will produce an output, and what will be the output? Output will be nothing but an amplified audio. Okay, so input is low level audio and output is the amplified audio. Okay, now to understand this phenomena a little better, let's discuss the uh, analogy of signal and systems. Okay, let's discuss the analogy of system and signal and systems. Now coming to the analogy of signal and system, I wanted to imagine a system, central government as one system. Okay, central government is one major system. Okay, it is a big system, right? Of course, central government is a big system, and it consists a lot of subsystems, small system which will be part of this whole central government. Okay, so what will be the subsystems? The system which will be the part of the central government. The subsystems will be you can say finance department, defense department, foreign department, right? Then home affairs, cultural, agricultural, right? Social welfare department, industries, human resource departments. All these departments will will be a independent subsystem. So you see, all these departments are functional blocks for my central government, which is a big system. All these departments are subsystem, which are functional blocks for my central government or a big system, right? You can call it functional blocks or you can call it set of elements, but they together forms a big system. Okay, now what will be the input of this whole big systems? If you think about it, the system input will be in the form of revenues which will be generated, like taxes, you can say, income generated from import, right? Complaints in applications, or proposals for financial aids, you can call social issues, business suggestions, right? Policies for foreign countries. All such things will be inputs. And if you pay close attention, that all these things are uh, having good resemblance with definition of signals, right? Because there is something that is close to a function. Okay, function with either one or multiple in variables, right? Most of them having multiple variables. You won't find in practical examples a signal having only one independent variable. Okay, there will be multiple independent variable. So this will be my input signals. Now coming to the output signal, what will be the output signal? If you pay attention towards it, the output signal will be firstly this uh, central government will process this input signals. It will take revenues, it will take all the import money, then complaints and applications, proposal and finance. It will process on it, it will do some work on it, and it will give us the output. Okay, so what output will be produced after getting done with uh, after system gets done with input? So uh, import was an input, so we will get export as an output, right? What will be other outputs, right? What will be the other outputs? So it can be government resolutions, it can be financial aids, right? We receive financial aids, government functions, right? Orders to states, various amount of orders which are given to individual states, that can also be considered as an output, right? Welfare programs, plannings, law and order, uh, elections, business policies, defense policies. All this will be the outputs of that system. Okay, so based on these central government model, you can understand the analogy of signals and systems. Now let me come to different um, types of signals. First is one dimension and multi-dimension signals. So what is a one dimension signal? So one dimensional signal is nothing but the function which depends on the single variable only. When your function is dependent on the only one variable, then that signal is called one dimensional signal. For example, you can take the speech signal. Speech signals are one dimensional signals. Similarly, let's come to the multidimensional signal. What will be the multidimensional signal? Opposite to one dimensional signal, multidimensional signal will be function which will depend on two or more variables. A function which will depend on two or more variables. Okay, for example, you can take image. Image is always a multidimensional signal because it is a 2D signal. One dimensional is 1D signal. Image is always a 2D signal. Okay, it has rows and columns. Every single image is formed of multiple pixels, and pixels are connected in rows and columns. So image is basically a matrix of pixels, matrix of values between 0 to 255. So image is nothing but a 2D signal. It is a matrix. 2D signals are normally called matrices, right? So image is nothing but a matrix, and it is a multidimensional signal. Now there are various ways in which we can classify our signal. So classification of signals can be classified, and there are so many ways to classify signal. Okay, so we have done, we have formed pairs to distinguish different type of signals. Okay, so signal can either be continuous signal or it can be discrete signal. It can either be periodic signal or non-periodic signal. It can either be even signal or an odd signal. It can either be energy signal or it can be a power signal, or it can be a deterministic signal or a random signal. So what is continuous and discrete signal? Continuous signal, it is nothing but a signal which can define continuously with respect to time. Okay, signal which is defined continuously with respect to time is nothing but a continuous signal. And signal which is defined only at specific intervals. Okay, specific intervals at regular time, those signals are called discrete signals. Okay, if that does rings a bell about continuous and discrete signals, that most of the digital signals are discrete signals. Not most, almost every single digital signal is a discrete signal. And about analog signals are mostly continuous signals. Okay, then periodic, non-periodic. So periodic signal is signal that repeats at regular intervals. It repeats after a certain amount of time. Those signals are called periodic. Signals which do not repeat after certain amounts of time, signals which are completely different at different amount of times, are non-periodic signals. Like if you see the sine wave or cosine wave, they repeat after a certain amount of time. After they finish their cycle, they repeats itself. So those were called periodic signals. Instead of that, if you see the signal for x raised to 2, or if you see e raised to x, those signals do not repeat themselves. They are different at different times. So those signals are called non-periodic signals. Then there is even an odd signal, which is also called symmetrical and non-symmetrical signals. So it is pretty much self-explanatory that signal that is symmetrical and non-symmetrical, right? So signal is said to be even signal if inversion of time axis does not change the amplitude value. Don't worry, we will be discussing all these signals in the detail. I'm just giving you a glimpse of each and every signal. So don't get scared if something does not make sense right now. Okay. Then the signal which is said to be signal is said to be odd signal if the inversion of time axis also inverts amplitude of the signal. Okay. There is a condition for both even and odd signal. The definition does not make it very clear, but when you see the condition that even signal, when you give a negative input to an even signal, it will give you the positive output. But if you give negative input to the uh, odd signal, it will give you a negative output. So we will discuss the conditions for a signal to be in even and odd in upcoming lectures, most probably in the very next lecture itself. Then there is a energy and power signal. Okay, I think it will be best if we give the conditions for a signal to be energy and power signal. That way we will be able to learn the signal very those signals very easily, right? But for in general case, we call a signal is energy signal if its normalized energy is non-zero or finite. Okay, and a signal is a power signal if the normalized power is non-zero and finite. Then the deterministic and random signal, which is very easy to explain, most easiest to explain among this. The deterministic signal is the signal which can be represented by some certain expression or a certain equation. Okay, if I'm telling you that a is equal to 5 sine omega t minus 120 degrees, then that is a deterministic signal because there is an equation that is defining it, and based on that equation you can plot it. But signal is called a random signal, that signal if there is not a single equation which can define that signal, which means your signal is moving very much randomly. So that was about the classification and classification of the signal. We will see each of them in detail, and we will give the conditions for each signal to be held its periodic or even or property, periodic property, even order, energy, power, signal properties in the upcoming lecture. So as this is the very first lecture, I'm keeping it till here in the first lecture. From next lecture onwards, we will be discussing this classification and properties of a signal in detail. Then we will be seeing classification and properties of system in detail. But in the meantime, I would want you to go through the mathematical equations if you have forgotten about uh, about derivation and integration, the basics only. I'm not I'm not about to tell you that to go in the details, but just uh, brush up those mathematical equations so that it will be easy for you to understand the upcoming lectures. All right, so I'm keeping this lecture till here. I'll be seeing you in the very next lecture. And as this is a lecture series, I will be uploading the lectures, 2 to 3 lectures every week. I will try to do it as much as possible. So that's what I had from my side for today. I'll be seeing you in the next lecture. Goodbye for now. Take care.